Hello everybody and welcome to Learning at Home with Mrs. V. So today what we're going to be doing is we're going to be adding and multiplying fractions. I know you're probably thinking, well, why are we doing both? Well, you know that multiplication and addition are related, and multiplication is just repeated addition, and we're going to throw in some of those units or some of those types into this adding with fractions also. So, first of all, I want to review what an improper fraction is. Remember, a proper fraction is when we have the numerator is less than the denominator or smaller than the denominator. Well, an improper fraction is when the numerator is larger than the denominator, and we know that that value is going to be more than 1, and we can create a mixed number from that, and it's easy to do by decomposing that fraction. So what we're going to do is we're going to look for those, and if we find them, then we'll deal with them as we come to them. All right? So when you are adding a fraction, if the denominator is the same, it's really simple. All you do is you take that denominator and you put it at the bottom. You don't have to do anything to the denominator, okay? As long as they are the same. So here we've got all of these denominators are the same. So we're not going to have to do any finding common denominators yet. So we're all set to do our adding. So we've got 2/5 plus 1/5. Now you remember when we were decomposing fractions, we wrote out these addition problems. So these should be pretty simple. So if we have 2/5 plus 1/5, then we have 2 plus 1 is 3, and we bring the fifths across. We've got 3/5. All right? So if we have 1/3 plus 1/3 plus 1/3, we've got all of the denominators are the same. So we just take the denominator and put it across, and then we add the numerators. 1 plus 1 plus 1 is 3. Now, I notice I can do 3 divided by 3. Remember what we said about that. 3 divided by 3 is going to give me a whole number, and actually it's going to give me 1. So I can go ahead and change that and make that into 1 whole. All right. So now, again, I have all of my denominators are the same. They're all tenths. So I'm simply going to write tenths. 3 plus 3 plus 3. Well, that's 6, that's 9. 9/10. I still have a proper fraction. My numerator is not larger than my denominator, so I don't have anything more to do with that. Okay? Now here, this looks a little confusing, but if you remember repeated addition, it's asking me to do 2 of these. Well, I could just rewrite that. I could rewrite that as 3/4 plus 3/4. That's what it's asking me to do. It's asking me to do 2 of the 3/4. That's pretty simple. 3/4 plus 3/4, and then I also have to do the 1/4 with it. So I've got 3 plus 3, that's 6, plus 1 more is 7, so that's 7/4. Now I notice my first improper fraction. Here's my improper fraction. My numerator is larger than my denominator. So I'm going to go ahead and try and decompose this. Well, I've got fourths, so 4/4 would be pulling 1 whole out of there. So there I know that this is going to be more than 1. And then it's also going to be, I have 3/4 left. So 1 3/4, 1 3/4 is the same as 7/4. All right, so I hope you're seeing how to do this. Now this is all with common denominators, meaning all of the denominators are the same. Remember to just pull that denominator across and then add up your numerators. If you come to something that looks like this, all it's asking you to do is to take that many, that many times of this number. So what I did was, or this fraction. So what I did was I took that fraction, it said I need 2 of them. So I just put them down like that. Simple, pretty easy. All right, so let's do a few more of these, and then I'm going to move on to something a little different. And it's going to kind of introduce you to how easy it is to multiply fractions. All right, so let's go ahead and do 4/9 plus 1/9 plus 2/9. All right, So what is that going to be? So I've got all of my denominators are the same. So then all I have to do is add 4 plus 1 is 5 and 2 more is 7, 7/9. This is a proper fraction. I have nothing else I need to do with that. Okay, so let's do 5/8 plus 6/8. All right, so I've got my common denominator. So all I have to do is rewrite that and then add my numerators. 5 plus 6 is 11. All right, so I've got another improper fraction. My numerator is larger than my denominator. So I can decompose that and take out 8/8. That's my 1 whole. And then I've got to figure out how many 8ths do I have left? Well, I have 3 of them because 8 plus 3 gives me 11. So 1 3/8 is the same as 11/8, 1 3/8. Okay? All right, so let's do 4 times half plus 3/2. Okay, so what does that mean? That means that I need 4 halves. So I can write that as 1, 2, 3, 4 plus 3/2. 1, 2, 3, 4 halves, because that's what it tells me to do. That's right there. Okay, that is this. So now I've got 1 half, 2 halves, 3 halves, 4 halves. So that's 4 halves plus 3 halves. So that's 4 plus 3, which is 7 halves. All right, now I have to change this because, again, I've got an improper fraction. So if I take out 1 whole, which would be 2 halves, okay, and I take a look at this, well, I think I've got another whole in there, so I've got another 2 halves, that's 4. Oh, let's try another one. There's 6, and then I have another half. So I've got 2, 4, 6, 7. So there's 1 plus 1 plus 1 plus half, which equals 3.5. So this would equal 4 times half plus 3/2 would be 3.5. Okay, so I'm hoping you're seeing how to do these. These I think you will get pretty quickly because you guys are really good with seeing patterns and understanding. And as long as you're remembering how to decompose the numbers, changing them from an improper fraction to a mixed number shouldn't be any problem for you either. So what would you do if I said to you, I want you to take 6/7 and I want you to write this as a multiplication problem? Well, again, we've got to get a common denominator, we've got to continue using the 7ths. Okay, so we're going to continue using the 7ths all the way through here. So all I have to do is figure out how to show my 6/7 as a multiplication problem. All right, so when I'm showing my 6/7 as a multiplication problem, I have to remember how to, all I have to remember are my basic facts. So when I'm showing my basic facts, I need to remember to do this as repeated addition also. So I can show this as 2/7 plus 2/7 plus 2/7. 2 plus 2 plus 2 is 6/7. So there's my addition. Now how can I change this and make this into multiplication? Well, how many 2/7 do I need? I need 3 of them. 3 times 2/7. So 3 times 2/7 gives me 6/7. Okay, now I could have done this a different way. I was thinking about that. That's why I was thinking, how do I show you a different way to do this? So I could also do 3/7 plus 3/7. Okay, and how many of those do I need? Well, I only need 2 of them. So I could say 2 times 3/7. Now notice 3 times 2 gives me 6. 2 times 3 gives me 6. So there's more than one way that I can show this as a multiplication problem. All right, so let's do another one. Let's do 9 halves. 9 halves. All right, so how can I break this down and show 9 halves as a multiplication problem? So I could do, let's see here, how can I break that apart? And I could do 4 halves plus 4 halves plus 1 half. All right, so I've got 2 of these, so I can do 2 times 4 halves plus 1 half. So I'm showing 2 of these, 2 4 halves plus 1 half. So when I show this, when I write this out, that becomes this as an addition. So that's the repeated addition of that. So there's the 9 halves, okay? All right. And that's showing it as a multiplication, but it's also showing it as an addition as well. All right, now what about, I'm going to go ahead and erase this. And let's try 27/5. Okay, well, I've got fifths, so I want to show this as repeated addition. So I could do, let's do 10 fifths plus 10 fifths. That gives me 20 fifths, and then I have 7 fifths left over. So that gives me 10 plus 10 plus 7 is 27. So I can do 2 times 10 fifths, because I'm showing 2 of them, and that's what it is. That's repeated addition, is the multiplication, and then add the 7 fifths. And that would be showing this as a multiplication problem. All right, so let's go ahead and try one last one, and let's do 12 tenths. All right, 12 tenths, I could do 6 tenths plus 6 tenths. That would give me 12 tenths. So how many of those do I need? Well, I need 2 of them. I need 2 times that amount. So I need 2 times 6 tenths. Do you notice 2 times 6 gives me 12? And then my denominator stays the same. So there's 2 of those. And I also can rewrite this, and I'm going to show you this. This is something that that we'll be talking about later on, but I think it's important to bring up right now. This 2 whole, can also be written as 2 over 1. Now if I do 2 divided by 1, I get 2. So 2 divided by 1 equals 2. So this is another way to show that whole number. So if we need to show that whole number, and we want to show that with a denominator, we could do that. We could do 2 over 1 times 6 tenths, and these 2 are exactly the same. These 2 are equivalent to one another, okay? So you can show it as the whole number, or you can show the whole number like this. It just depends on how you want to do it. Okay, so we're going to be talking more about this in class, but this is kind of mixing together the adding and the multiplying, and this is reminding you too that addition is related to multiplication, and that repeated addition gives you multiplication. All right, we could add up 3 plus 3 plus 3 plus 3, or we could say 3 times 4 is 12. So you can do it either way. It's much simpler to do the multiplication than the repeated addition. However, we can show it both ways. As we did here, we showed it as the repeated addition, and then we also showed it as the multiplication form. So you can kind of see how those are interrelated also with fractions. All right? I want you to keep watching, keep thinking, always stay curious, and I'll see you next time.